In this video, we will explore the idea of doubling time. Any exponential function that has a growth factor of greater than 1 will have its output value double over some interval of the input value. As an example, suppose you invest some amount of money and your investment grows by 5% per year. Eventually, your investment will be worth double what you initially invested. This idea is so important that we coin a term, doubling time, to refer to how long it takes for the output of an exponential function to double. Or more specifically, what change in input is needed for the output of the exponential function to double. So how might we actually determine doubling time, or how long it takes for an exponential function to double? Right now, we don't quite have the algebraic tools to determine this, but we can do it graphically. So suppose you invest $4,000 into an investment account, and the value of the investment grows by 5% per year. Let's determine how long it takes for the investment to double in value. So let's let t be a variable that represents the number of years since you invested. So number of years since investing. And then we'll let the variable v represent the value of the investment after t years. So we'll actually define this as a function. So let's let v be equal to f of t, where this function gives us the value of the investment in dollars t years after you invested. So we'll just write the value of the investment t years after we invested it. Since f of t represents the value of the investment, and we started with $4,000, then we can write f of t equal to 4,000 for our initial value, and a percent change of 5% corresponds to a 1-year growth factor of 1.05. And therefore, f of t is equal to 4,000 times 1.05 to a power of t, where again the 4,000 was our initial investment value, 1.05 is our 1-year growth factor, and then we raise it to an exponent of t because we have exponential growth. If we want to know when the investment doubles, we want to know when our output, f of t, is equal to 2 times our initial investment. So we want to know when this is equal to 2 times our initial investment of $4,000. Now to solve this equation, it's the same equation as 4,000 times 1.05 to the t is equal to 2 times 4,000. 2 times 4,000 is just equal to 8,000. To solve this equation, we'll actually just take a graphing approach like we've done in a previous video. So to do this, we'll graph both our original function, so we'll graph this function f, and then we'll also graph v is equal to 8,000. So corresponding to this equation right here, we'll graph v equals 8,000. So take a moment to plot those two things. Your plot should look something like this. We have the exponential function f right here, and then we have the line v equals 8,000, so an output value of 8,000. And these two plots intersect at this point right here, 14.21 comma 8,000, which tells us when t is equal to 14.21, f has an output of 8,000. And therefore, this value of t, this 14.21, is the solution to our original equation that we were trying to solve right there, which tells us how many years after investing our investment will be worth double. So it takes 14.21 years for our investment to double. So we actually call this number right here the doubling time for this exponential function. So this is the doubling time. Now, an interesting artifact of exponential growth, if we instead invested some other amount of money, so changing this 4,000 to any other amount, that would result in changing our function definition a little bit, as well as the output value we're looking for. So if we change that 4,000 to any other positive number, and we go through the same process, we're always going to find a doubling time of 14.21. So this 14.21 does not depend on the initial amount that we invest in. It only depends on the percent change or the 1-year growth factor. So it doesn't matter how much we invest, it'll always take 14.21 years for this investment value to double if it's increasing at 5% per year.